Hey everybody, Tom Cherry Holmes here with FujiNet and Errata Online, and I wanted to do the last video of the year here showing some improvements that have been made with Multilator reliability and performance improvements. The biggest thing to note, if we actually go into the code here, if it'll let me go in here, pardon my system here, it seems to have Arduino seems to have flaked out a little bit there. Okay. If we actually go in and have a look at what we've done, the biggest thing that's happened is that the TNFS functions themselves are now properly responding to retries. As it turned out, duration wasn't being set, and so this thing was going into a black hole of coming in. If a packet wasn't responding, the whole device would just simply stop responding. So now, not only are we doing that, we are doing multiple retries, 5 retries max, and we are also properly resetting the retry packets, and most importantly, we are retrying with the existing retry count packet to leverage the fact that that TNFS will send the same packet again if the retry count is the same as the previous request. So this has a number of profound implications here, and to test the reliability of this, we will actually show on the next screen here my setup. Let me go back in here, and we will actually go into my copy of FujiNet here, hit the reset button, which will cause config to boot up on the next run. Now, we may actually hit a point where when we do something here, the corresponding write will time out. This is a known issue, and I'm trying to work through these. These are SIO timing issues that we actually need to work out here. Now, to talk about my setup here a little bit here, you'll see some existing slots of things that are in place. If we look at devices, for example, we'll see sector copier 810. That is being loaded from my local TNFS server here. The next one is empty because that's my drive 2. That is my 1050. Spelunker is actually being loaded from FujiNet Online. And blank 90 is the other one here that I'm going to show, and that is actually being loaded from my Google Cloud server way over on Google Cloud land. And this just kind of shows you these are all different hosts. They're all hosting different disk images for this particular test. But you'll see that the Atari isn't any the wiser that this is actually happening. So with that, we'll go ahead and start up. We hit the Option key, and you'll see here that there's a slight hang as it takes and attempts the write. It attempts it again after the timeout has elapsed, and it boots the system. Now, we'll see here a sector copier that's pretty commonly known here. Just nothing too special about it. We'll actually take and start by, for example, let's take and copy what's in drive 3, which is Spelunker. Let's copy it to drive 2. Now, for reference, we have here an Atari 1050 set up as drive 2. And we'll go ahead and set that up. We'll go ahead and format the disk just to be safe, sure. And we'll go ahead and write blank sectors just to be sure. And we'll start. Now at this point, it's actually reading Spelunker off of FujiNet.online. You'll see the slight pauses here that are happening. This is literally because, again, of the track buffer. Now, one thing to note, Multilator also has double density support in it as well. And the track buffer size is exactly the same regardless of whether or not you're using single density or double density. The difference is with double density that half of the number of double density sectors are read versus single density sectors. And honestly, for the type of traffic that comes across with the network, this is just fine. It keeps the performance up, and it keeps the memory requirements down enough so that we can fit this even on 8266 devices, which is very important because there's only 80K worth of RAM. And you'll see right here that we're writing to the 1050, and it's just happily writing everything down here, doing a great job. For the next test, we're actually going to take and do the sector copy to another disk image that's sitting on my Google Cloud, which is drive 4. And you'll see that the process is exactly the same, and the Atari is none the wiser of what's happened. Where does this leave us? Well, some things that do need to happen. We need to actually hook up the SIO error mechanism for TNFS requests. If 5 TNFS requests happen and they all fail, then we need to return with a command error. This will cause an error 144 to actually happen. And I think this is actually the correct error to happen in this case, because it would be equivalent to, say, a write protect happening when you're trying to do a write or that sort of thing. So we need to hook that up. We also need to take and investigate these timing errors that are happening. Right now, our timing on the 8266 is extremely marginal. It's doing great 90% of the time. 10% of the time, it will hit a hiccup, and something will happen, it will slip in timing, and it will cause a timeout to lapse and the command to happen again. Now this causes essentially a noticeable pause whenever these timeouts actually happen, and we need to figure out why this is happening. And to this effect, I'm actually getting a logic analyzer to actually take and borrowing a logic analyzer to take and analyze this traffic. So we need to figure out why that's happening. If you can help with that, that would be great. That would be so great. Anybody who can help with any aspect of this project would be very much appreciated. Seriously. So there's that. Meanwhile, Jeff Piepmeyer is working on printer emulation. We have proven that we can successfully write out PDF files from scratch without using any existing libraries. This is extremely important because, of course, we have very little memory to work with. So look for printing support in the near future. You can see right here that we are successfully reading and writing here to the 1050. The 1050 is verifying. This looks great. So far, so good. This is looking absolutely fantastic and coming across the network just great. And what we're actually going to do here after this, I'm going to take and flip the, I'm going to go ahead and flip the disk identifiers real quick for the 1050, and we're going to boot what we just copied over here. So with that, let's go ahead and do that. We'll go ahead and move over to my desk. And since I'm over here across the room, I'm going to talk a little bit louder. You'll see my hands come across here, and I am going to flip the drive selector real quick, put that into drive 1, and I'm going to reboot the FujiNet by hitting reset, and subsequently rebooting the machine. Oops. Apologies. Drive conflict. I did indeed do that, so let me turn the 1050 off for just a moment. Reset the FujiNet again. Hiccups, fellas. Sorry about that. We will take and boot into config real quick and remove the virtual drive from the slot so we don't conflict. Now you'll see right here, we've got a red right here because it sent the command to set the SSID but the computer has not responded yet. So it will time out, and within a few moments it will try the command again. This is some of the timing issues that we're talking about. So we'll go ahead, go to devices, and we're going to eject that sector copier real quick. And we're going to put the disk back in the drive here. Actually, 350 on. And we're going to try this again. Option to boot. And we're going to see in just a few moments Spelunker come up here. Now this is the Broderbund title version here, so it'll take a few moments for this to come up. It's still blowing my mind that I'm able to take and do a sector copy across the internet of a disk from a virtual one to a real one, and the Atari is none the wiser. So with that, we prove that, okay, this works. Great. Now, let's take this a step further, and let's reboot the FujiNet, and I'm actually going to turn the 1050 off for the rest of this. Oh, I shouldn't turn the TV on because there's nothing connected to the TV. That was a reflex, but that's fine. We'll take and reboot the machine here. Turn you off because I don't need you at the moment. And we will now go back in and remount sector copier. This is running on another TNFS server on the local network. Mounted into drive 1. And you'll see that drive 4 already has a blank disk in place. We'll go ahead and mount this as read-only because we don't need it to write to it. And we'll reboot. And you'll see right there, acting like just fine. Okay, and this time, we are actually going to take and do a copy from 3 to 4. And start again. And you'll see it picks up as if nothing. Yeah, it's nothing. Okay, there you go. We're just copying sectors off the internet just fine. What a time we live in. Seriously, it really is amazing to think about. So what's next for FujiNet? As I said before, fixing the existing reliability issues with a goal of getting all of the Diskulator functionality firmed up and getting ready to write the production firmware, which will be, for the first pass, will be the Diskulator. Now, once we do that, we'll actually start worrying about how to take and produce more of these devices, or more than just the testers. We'll look for that in the next couple of months as well. It's important to note that for each of these devices that we've created, doesn't matter which device you have, it might look something like this when we finish with it, or it might be one of the devices you got for testing, like this guy. But the point being that all of these devices use the same basic core, and thus can be updated entirely over the air. So as we get new functionality in place, we'll find that it'll work, it will work just fine as we add new features. You'll be able to test them and to use them and to take advantage of them when we push them out. So this will allow us to get devices into place, and by concentrating on the Disculator functionality, we're ensuring that the widest possible audience can have something useful with this device. Now, some of you have asked about cost, and the only thing I can say at this point regarding cost is that it's going to be very affordable. The price, I estimate that the price will be very comparable to an S-Drive Max. Even more so because the cost that we would normally be having to put against a display, we can instead put towards the faster, much faster microcontroller that is on these devices versus the Atmel AVR that is on the S-Drive Max, and thus we can do more. There's so much that this microcontroller will be able to do. I mean, the 8266 microcontroller starts at 80 megahertz. You can clock it to 160. The average running clock of an ESP32 is 240 megahertz with 2 cores. So we have a lot of processing power to do things like TLS and DTLS. So we'll be able to take and actually participate in the modern internet and make APIs that can securely connect to other hosts and even between each other with the end device that we're also going to be focusing on. So, right now, finish up the D device, get the R device working, and start seriously firming up the bits and pieces that make up the end device. That's the idea in the next couple of months. So now that we've done this, I'm actually going to take and reset again. And we are going to reboot the computer. And go back into config. Now see, you notice each time that I hit the reset button, it goes back into config to give me the opportunity to take and reset drive assignments. I'm going to use this. I need to add a swap command here. Yes, the drive software is still being worked out, but that's fine. I'm going to eject the sector copier, and I'm going to eject the blank 90 that we just made, and I'm going to put it right back up here. Now you'll notice right here that it hung here for a moment. Again, this is in apropos of the write timing issues that we have been experiencing here. This hang will happen for approximately 15 seconds, and you'll see that eventually the interrupts resume and everything, and key presses then come back. We can then go back to hosts, and I will go to my cloud here, mount the blank 90, and let's see if this actually boots as drive 1. It only. So now that's in place. We mount all the devices, and if everything goes as it's supposed to, we will see a copy of Spelunker being loaded off of Google Cloud that we literally just wrote to using a disk image from another internet host entirely. And it looks like so far, I think it's going to load. Again, I'm very happy with the reliability changes that I've made here to do packet retries. It has significantly improved the reliability over long-haul links. And some of you may be asking about high speed. Yes, high speed is coming. I've had it working. We just need to work out some of the mechanics for switching baud rate and get all of that resolved. And then I can take and pull high speed into So with this, I think I'm going to end this video. I'm just under the 20-minute mark. That's absolutely fantastic. So, I mean, until next time, guys.